He goes by Ashik.
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 Ashik. Hussein Ashik.
Just to make sure this only microphone is used for streaming, so please repeat each question from Q&A and be around.
Oh, my internet is not working.
So this should be, yeah. Choose some 4:3 ratio. If they're still missing something.
Yes. I just select 4:3 ratio, which means
It was 1400 to, if I remember well.
if. No, that's for this. I'm trying to remember how to change resolution on this thing. It's been a while. No, it won't. No, because I'm using free.
Yeah, it's only for the first one, so maybe forget about it. Or he is already on Wi-Fi, so he can use the Corsair live.
It's the desktop manager thing. I'm really out of it at the moment. There we are. So what's a good 4:3 resolution? I can't remember offhand.
Still falling. Yeah, probably 2 megabits. It happens.
Yeah. Let's do 1280 by 960. Yes. Yes.
Maybe try 14 to 150. 150.
Aha. Okay, so it's only on that one. Got it.
Yeah?
So after some technical difficulties, we have this presentation ready to go.
So our next talk is Hyper-converged persistent storage for container with Gluster. And please welcome our speakers, Jose and Mohammed Ashik. And Jose is a software engineer at Red Hat, working with the storage, Red Hat storage team. So please welcome for the talk.
All right, for the record, I will have it all know I had a very bad morning and I only got here about 5 minutes before this presentation, so bear with me. All right, as mentioned, my name is Jose. This is Ashik over here, and we're presenting a relatively new storage solution that will allow you to do hyper-converged storage natively on your cluster nodes with GlusterFS. All right, next. All right. Ashik, say a little bit about yourself here.
So, hi everyone. I work on Gluster containerization and hyperconvergence of Gluster on OpenShift and Kubernetes. So, whatever component which is required for hyperconvergence, I contribute most of.
Yep. And as mentioned, I'm Jose. I'm a member of the Samba team and the Kubernetes storage SIG, and I focus mostly on the integration code that managed to bring all this into an easily deployable scenario. All right, so we're going to go over sort of why we're doing this and what we're using for it. We're going to go over a rundown of just what work it took to get it all to this point. So we're going to go over in particular the containerization of GlusterFS up there. And then we're, hopefully, since I just got here, show you a demo of it working in action. All right, so why are we doing this? Well, the basic setup is that containers are ephemeral and a lot of applications are not. A lot of applications want to have persistent storage that lasts longer than the life cycle of a typical container. If the application goes down for some reason, it wants to be able to come back up and have its data that it stored be still there when it comes back. Given the nature of the work we're doing, we were looking to provide something that would require a minimal hardware investment so that you wouldn't have to buy any sort of external hardware appliance to do your storage for your containers. Was as simple and transparent as possible for both administrators and users who wanted to make use of the storage, as much as storage can be anyway. And something that is free and open source, which is why we're here. So our target platforms are Kubernetes and OpenShift, because Red Hat. And in particular, we see them as leading adoption in containers in general, both in open source and in corporate environments. And our component projects are GlusterFS and Hecketi. Lovely little logos there. GlusterFS is a distributed software-defined file system. Storage devices or storage devices called bricks are selected on one or more nodes in a Gluster cluster to form logical storage volumes. One of the biggest things about Gluster is that since it's software-defined, it can run on commodity hardware, even a Raspberry Pi, link in the PDF, and has a scale-out design. So it is easy to increase your storage simply by adding more bricks or more nodes to your storage. Gluster can bring all those together into coherent storage volumes and expand them as needed. And it also provides good distributed features like cross-node and cross-site replication, usage balancing, and as of recently, an iSCSI storage access method. Hecketi is the RESTful volume management interface for GlusterFS, meaning, of course, that you can use any REST client, even down as low as curl on the command line, to do most of the necessary volume management operations for a Gluster volume. In particular, this allows it to be done programmatically by applications. It can manage multiple Gluster clusters from a single instance and was designed from the get-go to be lightweight, reliable, and simple. Simple being the key word here. It is dead easy to use. And then finally, we have a little project on GitHub called Gluster Kubernetes that brings all these various projects and pieces together. We document on how to put it all together yourself. We provide a quick start guide so that you can bring it up yourself very quickly, either in your own environment or in a virtual environment that we provide. And it has an easy-to-use deployment tool, GK Deploy. That's where most of my work went. All right, creating hyperconvergence. Take it, Ashik.
Ahoy. I just wanted to tell. Hi, so I work on Gluster containers and the hyperconvergence of Gluster in OpenShift and Kubernetes. So the first task when we took about this solution was containerizing Gluster. So we needed to make the user space network file system inside a container. So that was our first task. Now it is running really good inside a container. And this is the complete command of Docker, which is used to run this container. So we have two base images maintained in upstream. We have CentOS Gluster image and we have Fedora Gluster image. And we have a lot of pull requests and issues there, which we are really working on. And it is really good to see the community coming up. So what this command actually does. So first, for a configuration, we needed all the Gluster configuration mounted from the container, from the host to the container. So etc glusterfs, varlib glusterd, and varlog glusterfs are all the configuration for Gluster required to run. So these things are given from the host, and we give the complete network stack of the host to the container, and we use systemd container, and it runs in a privileged mode. So I'm going to split this up. So this is how it looks like now. So why we came to this solution is what I'm going to talk briefly on. So systemd, it is a systemd container with privileged mode, which by-mounts the Gluster configurations from the host and has the network stack as host, and we by-mount the dev. And we have a startup script. I'll tell about the startup later. So systemd. Why we wanted systemd inside the container? So Gluster had a lot of process running along with it, and we wanted someone to clean up the zombie process after the process got completed. So we started with systemd containers with the help of Dan Walsh, and I think most of you know him. So with that, we needed privileged. So previously, to run a systemd container, we need privileges. So without privilege, systemd was not able to run inside container properly, but now it can run without privilege in container with the OCI systemd hook on the host. So we need privilege still now because we are storage providers and we need /dev of the host inside the container to create the logical volumes. So these are the three directories which is required for Gluster to maintain its configurations. So we didn't want Gluster configuration to be changed when a container respawn happens. So we by-mounted these containers, directories from the host to the container. So why we wanted to by-mount it? Because anyways we were tied to that host as the devices were only located in that host. So by-mount was a good choice for us to go on because anyways we can't move a Gluster configuration from one node to another because devices attached to that. So we also took host networking. For Gluster point, the IP should not be changed. So we could have done it with giving a constant host name, but we thought it will be better performing if it was in host networking. So we gave the host networking stack to the container. So /dev. As we all know, all the storage devices get inside this. So we need the /dev inside the container so that all the volumes which are required for Gluster to create is given from the /dev of the host. We have it running perfectly fine now. So we had few issues with udev. We have solved it in our containers. And the startup script. Startup script is really important when you are doing container stuff, and which is really big system kind of an application to containerize. So the thing about startup script is it manages to start the Gluster as it starts in the RPM installation. The configurations which you needed, everything is copied back to the by mounts of the host, and then we needed a perfect way to upgrade Gluster in case of upgradation of Gluster where it is taken care by hook scripts from the RPM installation. So we needed some place in the container to do that stuff. So we have a startup script inside the container which also mounts the logical volumes when a container respawn happens. So all the logical volume which was mounted will get remounted on restarts. So that's all about Gluster containerizing. This is on Hecketi containerizing. So Hecketi, as he said, it's a RESTful Gluster volume management tool. So what Hecketi actually does, it gets the whole control of Gluster nodes. Let's say if you have 3 nodes with 2 devices on each node. So Hecketi actually runs to manage those 3 Gluster nodes and those devices. So when you give a command in Hecketi to create a volume, Hecketi goes backend and creates the logical volume, PV, logical volume for that device, for that brick. Brick is the minimal unit for Gluster. So it will create everything required for the brick, and Gluster volume command gets all those entries of bricks and creates a Gluster volume from the network stack and gives it to consume from the native mount. So that's basically what Hecketi does. It gives those commands. It gives the whole abstract rather than any admin to go and create all these bricks behind the screens and do the volume create command and stuff. So Hecketi is managing all the Gluster volumes when you run Gluster inside Kubernetes or OpenShift, Hyper-converged. So it was easy to build as it was a small application which was really not as complicated as Gluster. So it was really easy to build. The thing which we came up with using the Hecketi was to get access to all the Gluster nodes. So it has to have the access to all the Gluster nodes. So initially, before hyperconvergence came into picture, Hecketi uses SSH exec to get inside the Gluster nodes and create the logical volumes for it and Gluster volume from it. So now we can't do SSH because we are in a Kubernetes world environment where SSH can be dangerous. So we used kubeexec. So for using kubeexec, we needed privileges or kind of a username authentication way. So we need a service account in OpenShift or Kubernetes to access all the cluster in the namespace. So Hecketi uses that service account and calls all the Gluster nodes to create LVs and create the Gluster volume from it. And BoldDB. So Hecketi uses a BoldDB, which is to maintain all the operations which was performed by Hecketi, to maintain all the devices which was attached to the nodes which is managed by Hecketi. So in case of persistence in the containers, we don't actually have any. So on a Hecketi respawn, this DB is lost, so we need to build it from the scratch. So Hecketi, how it does in the hyperconverged way is, it initially takes the Gluster cluster and creates a volume out of it, and it uses its BoldDB for that persistent volume. So it creates a persistent volume of Gluster, and BoldDB stays in the Gluster volume, and it is given to Hecketi to maintain the DB. So now let's talk about provisioning in Kubernetes world. So Kubernetes has its own persistent volume framework which can be used by any pod. So backend storage can be anything. It gives the abstraction to the users and the administrator to use the volumes. So they initially, admin has to go to the backend and create a network storage volume and create a persistent volume file. He has to create a Gluster volume backend and give it as a persistent volume file to users to consume it. So the persistent volume claim is where the user comes into picture. If I am a user who wants to run application and want a persistent storage of 5 GB, I create a persistent volume claim of 5 GB, and this 5 GB volume claim is bound to the persistent volume which was created by the admin. I'll talk about the storage class in some time. So So this is how the persistent storage in Kubernetes world or OpenShift world looks like. So admin has to go and create the network storage volume, which is given as persistent volume, and then the user will request for a persistent storage in persistent volume claim. So the request is then bound to the persistent volume, and you can see the status of the bound in the persistent volume claim, and the PVC is then used by the pod. So when a pod goes down and comes back up, all the data which is stored in the storage is not lost. It will again mount it back and use it from the state which it was killed or died. So that is how it works. So this PVC is mounted using just volume plugins in the Kubernetes. So Kubernetes support lots of volume plugins. So basically the persistent volume claim files, which is bound to the persistent volume, will have a mechanism to mount that kind of volume. Like in case of Gluster, so Gluster supports native fuse client. So in case of Gluster, the volume plugin actually does is it mounts the Gluster volume on the host where the pod is going to use the volume of Gluster, and then it bi-mounts the mount path to the container so that everything written to that bi-mount path will be persistent across the respins of the Gluster or of the application pods. That's how volume plugin in Gluster works. So PV is released only when the PVC is deleted, not when the pod goes down. For Gluster to be in a persistent storage in an environment where Kubernetes or OpenShift, these are the things which are required. So we need a service account. Service account is used to maintain the endpoint file, and endpoint file is actually where you mention the IPs of the Gluster nodes. If you have a 3-node cluster, you will give all the 3 nodes IP which is used by Gluster in the endpoint file, so that when you mount these volumes, it will check the endpoint file and take the IP and mount it on your local and give it to your application pods. The persistent volume file, there is a persistent volume file with respect to Gluster because it has a persistent volume plugin inside Kubernetes. So the name which you mentioned makes use of this plugin. So persistent volume claim of Gluster volume will then map to the persistent volume of Gluster, and application pods or the users can use Gluster volume from it. So what Kubernetes does to reduce all the steps where the administrator is required in case of a volume request is dynamic provisioning. We have a dynamic provisioning plugin inside Kubernetes now. So you don't have to worry about the endpoints anymore. You don't have to worry about the service anymore. You don't have to actually worry about the PVs, which has to be created by admin on request. So only a persistent volume claim is required now to get a Gluster volume out of Kubernetes if you are doing hyper-converged Gluster, or even without hyper-converged Gluster, this solution is possible. So this is the parameters of storage class. So storage class gives an more user-specific volume creation in case of Kubernetes or OpenShift. So I'll tell in Gluster world. So this is the Hecketi data. So REST URL is where the Hecketi lies. So you talk to Hecketi through storage class, and this is the cluster ID. So Hecketi can manage more than one cluster of Gluster. So multiple clusters Hecketi can manage. So if you say there is one cluster of Gluster which is of 3 nodes and has backend as HDD device, and one more cluster of Gluster which has let's say some more faster devices. So you have two clusters in Hecketi. So if you want to provision faster storage for a user who is privileged or something, you can mention the cluster ID in the storage class. So this will create the volume only from the faster storage and not from the slower storage in the Gluster cluster. So REST user is the username for the Hecketi user, and the secret name is used for Hecketi authentication purpose, and GID min, GID max is the security option which hyper-converged Gluster provides. So you set the GID on the volume, so that only with that GID you will be able to access the volume. Other than this GID, you will not be able to access the volume. So this is the security feature which we support in Gluster hyper-converged. So that's it.
Alrighty. So, as mentioned, we have now achieved full hyperconvergence with Gluster and Kubernetes. Just to go over some of the quick high points here. This hyperconvergence scenario requires still some administrative changes, especially if you have an existing Kubernetes cluster. You need to open up a couple ports and such that Gluster requires. But otherwise, this greatly reduces the hardware cost, because if you don't have any existing storage, all you have to do is attach a couple SSDs or something to your Kubernetes nodes, and you're good to go. Applications now have native access to GlusterFS backed storage via Hecketi, and it's also fairly flexible in that the Gluster containers don't have to run on every node of your Kubernetes cluster. So if you only have a certain subset of nodes that you can add devices to, or that you want to add devices to, just spin the containers up on those nodes, and you can go from there. And as with keeping of the promise of Gluster, this is relatively easy to scale out. All right, demos. Now let's see if this works. Let's see here. There we go. Don't worry. Let's see here.
Can you change your font?
Easily. Step 1, make it big. All right. So let's see here. Let's start by, all right, so I have a 4-node, effectively, Kubernetes cluster running. Let's see. And I have a couple pods running there already, although the screen is smaller than I anticipated. Let's see. Aha, thank you. So we have a couple pods running here, all in the default namespace. Let me edit something real quick, because this will be important later on. Okay, much better. So we have some endpoints, a service account, and some secrets. Nothing else running just yet. So then, using our handy deploy tool. First of all, so we're going to use our deploy tool there. But as part of setting up Hecketi, we need something called a topology file. Let's do less here. This topology file lays out the topology of your storage devices and where they lie in various Gluster nodes. So you can see here we have the node hostname, an IP address, the list of devices that are on that node, and then we also provide a field for something called the zone. This is basically just a number. You can give it any number you want, but each number logically represents a different management zone, so that Hecketi knows, Hecketi can, if you wanted to, balance storage between different zones. This is useful for something like, geographic replication from one site to another. And then, yeah.
A Hecketi file or a Kubernetes file?
This is a Hecketi file specifically. And this is formatted in JSON. My condolences.
Can I ask one thing? Why you must give their devices? The Hecketi cannot scan the
We don't want to do that, because Hecketi Hecketi assumes full control of all the storage devices that you give it. This means that it will format it and put LVs and PVs on there by itself. So if you have it scanned for storage devices, it might overwrite your root file system. Thankfully, it does not actually do that.
But it's going against the cluster file system, probably you won't have a root file system on cluster, and that's okay.
Yeah, but like if you can specify the storage device that has your main file system on it. So let's see here.
Can you add new devices on the fly?
Yes, of course. Of course, yes. Sorry, like I said, I just got here 20 minutes ago. My brain is not all where it should be. So let's see if I can do this right. So we specify our deployment tool, we specify our topology file, and because we don't have Gluster running just yet in this case, we will specify -G to tell the deployment tool to deploy Gluster. And then for the purposes of this demo, I'm going to run it in verbose mode just so that we don't sit there waiting too much on empty dots. All right. It brings you, so this handy tool brings you over some considerations and requirements for doing all this deployment. In particular, that you need to have, of course, administrative access to your Kubernetes cluster, and you need to have installed the command line Hecketi client, Hecketi CLI. Your nodes will also need these list of ports open on there, and you can see the last ports there. They're variable depending on how many bricks you're going to have in your Gluster cluster, but in general, we recommend about 100 or so. That should be fine for most deployments. All right. So we've deployed the Gluster pods. We're waiting for them to create. I've already downloaded the Docker images ahead of time, so we don't have to wait for them to download. And this should take about 12 seconds, I think. Nope. Should take less than a minute. Let's see here. They're running. What we're doing right now is just waiting for all the resources of the container to attach to said container. Why this is taking so long, I'm not sure, unfortunately. Let's see here. Come on. You can do it. Nope. We are going to run over a minute here. No.
Does it have to Docker pull the images?
No, I already pulled the Docker images. That's the thing.
You pull Kubernetes pods.
Just a minute. It took just exactly a minute.
Woohoo! Perfect. All right. No, I can't take credit for that. That is slightly over a minute, yes. It just, Kubernetes stops reporting at the interval of seconds and then just reports every couple of minutes or so. All right, so here's where some of the magic happens. Hecketi actually deploys twice in this scenario. First, it deploys a deploy Hecketi pod, or a pod called deploy Hecketi, that will take the topology file and add all the storage devices and all the nodes. Then it creates a job to copy its new database, or to take its database, create a new Gluster volume, and copy its database into that Gluster volume. Then you destroy that pod and create the end Hecketi pod that will now come up and run pointed to the Gluster volume as its main database storage. And we're running. Let's see here. So, alrighty. So we have our Hecketi service. And then, let's see, if I just do curl AD / hello? Hello from Hecketi. All right, now let's do something interesting with this. All right, so here I have a storage class. Actually, I need to edit this briefly. because we have our endpoint as the Hecketi storage endpoints, and as Ashik mentioned, that is a pointer to all the Gluster nodes that are currently in the cluster. And then we need the REST URL for actually getting to Hecketi, which I need to put that in there. And for the purposes of this demo, we're running with very minimal security, so we don't need to really enter a real REST user or REST user key. All right. Gluster storage class created. Then we have a Gluster persistent volume claim. Now, this is something that you would submit as a user. So the work of the administrator is now done. Now I'm technically transitioning over to the role of a Kubernetes user. So I want to request a 5 gigabyte volume on that is of type Gluster Hecketi. I just created the storage class Gluster Hecketi as the administrator, and now as the user, I'm going to do kubectl-f PVC, volume 1 created. And as we can see here, the PVC has been, you see, let's see if I can, you see up there where it says PVC Gluster 1, that's the PVC I just submitted. Below that, you see the storage class initially created. And here you see the persistent volume that was dynamically generated from the PVC. And then we will spin up an Nginx pod. This is a fairly basic pod about about the most basic we could get for the purposes of this demo. And it just sets up an Nginx instance, port 80, and in particular puts its main HTML storage in a Gluster volume, the Gluster volume we just created. And for this one, I also prefetched the container image, so hopefully this one should hopefully run less than a minute. We'll see. You can see the Nginx pod there is currently in a state of container creating, and it's running. Oh, wait. And it also created an Nginx service here, which I'm going to need. All right, so we're getting data. Now I'm going to do some slight command line magic here. I'm going to do a kubectl exec. So I'm going to go into the Nginx pod and echo some data to index.html. And this will effectively write the data onto the Gluster storage volume. And then if we do a curl again, we see hello world from GlusterFS. Now, just to show you, as much as I can show you that this actually did something, I'm going to go into the container itself, or into one of the Gluster containers. Oh, let's see here. I changed hex on me. Okay. Alrighty. And we're going to look for mounts which are managed by Hecketi. All right. There we are. So let's see. The first one here I just know is the volume mount for the Hecketi database. So we're going to go to the second one. Let's see, and then cd that ls, we go into brick, ls, oop, I did pick the Hecketi DB one. Let's see here, mount, grab Hecketi. Varlib Hecketi DB. Oh, where is it? Yeah, let's do another container then. There we go. This is more like it. cd brick ls cat index.html. And there, that is the string I just wrote on Gluster storage. And that's it. So let's see, we go here, F5, demos, and thank you very much. Do I have time for questions? All right, any other questions? Right there.
Sorry, this seems like a long question, but just to clarify in my mind. So you pointed out that you have your cluster containers, which you can move to different machines because they're tied to physical storage. So if you're doing all of this, what is the point of having Kubernetes, and what is the point of having this in a container at all? If you can't just pull them and move them at will.
The question is, what is the point of having all this in Kubernetes and in containers at all? The point is not, yeah, if you can't move them. The point itself isn't to sort of bring the ability of containers to Gluster, is to bring Gluster to other containers. So other containers can move around inside Kubernetes, and they can use Gluster volumes natively within Kubernetes as Kubernetes storage. And they can do that from anywhere in the cluster. Convenience.
Also, in case of atomic host kind of environment where Kubernetes is running, so in that place you can't install actually any RPM on the atomic host, right?
So it's just for the fact that you want to run on it.
Yes, this is
also
this is a shared infrastructure, right? So you've got your OpenShift deployment or your Kubernetes deployment. You may not easily be able to get to the existing storage deployments, right? So you've got your cluster infrastructure ready. Rather than having to buy new infrastructure for storage for that thing, you could run it all within the same shared infrastructure.
You gotta have storage.
so yeah.
Data.
So yeah, it's shared infrastructure. Yeah, it's shared infrastructure in the fact that you might be running on something like Atomic, in which case you can't just install Gluster on the host itself. You can instead install it as containers on the nodes. Yes.
What about backups of the data? How can you back up GlusterFS cluster, let's say? What do you need to back up first, and how can you take the data out of them?
So you're talking about snapshot kind of a thing for a volume.
For example, or also back up the data. So if I'm thinking about this in production environments, I need to have a way, how can I get the data out?
All right. The question is, what about backups? How do we get the data out? And as far what?
Snapshots.
And then yeah, the answer to that is snapshots. You can take snapshots of the Gluster volume. Can you speak more to that?
Yeah, so you can take snapshot for the volumes, and also there is replica 3 volumes. So in case one pod goes down, Gluster pod goes down, so it's okay. You can still serve from other 2 nodes. So all the volumes are created as replica 3. So one cluster going down will not harm your mount point or applications running with the volume from Gluster.
So we are thinking here about Sieve-like, let's say, if you know what Sieve, the Sieve product, which is basically again another, I think it's Red Hat based. It's similar to GlusterFS, but it's doing also storage.
Ceph storage,
yes.
okay.
Okay. Yes.
Ceph storage, yeah.
All right. I don't know. I mean, as far as getting the data out, you could. I mean, any backup solution that can access a file system can easily extract the data.
Yeah, but the point is then at which level? If you want to take it either at the container level, either at the storage level. So I would think about the GlusterFS as my, let's call it backend storage. Like,
Okay.
I don't know. So either, it really depends where I want to take the data. Because
Yeah.
I see that the mount points are not easily guessable, so you need to have at least a way how you can get the data and map it to something. So I see that a little bit complex to make a backup solution.
I mean, yeah. In that case, if you want to go down to the raw storage and extract your data that way, then yeah, I think that gets a little complicated. But
Yeah, so just something you can consider, right? So you
Yeah, but you would still have to use Gluster for that one. You would still need the Gluster layer on top of that for that one. So you don't have to go and guess all the underlying storage, like you said.
Okay, so we will have a sort of API outside it, which is asking GlusterFS how to, which is telling GlusterFS, okay, I want a snapshot here, and then I will mount the snapshot somewhere else, and I will do the backup. That's the way, I guess.
So Gluster has a feature inside saying you can create, if you want snapshot, it's just a command in Gluster to create snapshot. But for now, we don't support it in Hecketi because Hecketi is a layer where you can access the Gluster volumes. So we have it in like really near future. We'll have that because it's really hard for us.
So the answer is that no backup yet.
No, you can't do it. Like you have to manually go to the Gluster container and do a Gluster snapshot command, which will take the snapshot of the volume. Then you can use the same volume to restore your data.
So yes, there are ways of doing it, just not through Hecketi at the moment.
Hecketi, yeah. It's
all right. Let's jump over here.
You can use cluster volumes as secrets in Kubernetes. The question is, can you mount subdirectories of the
no, we don't have subdirectory feature in Gluster yet.
Is plan
Kaushal
to know
knows.
when or
So
something?
Kaushal knows.
Planned for a long time. Hasn't been implemented yet.
Okay.
So there have been review requests for a particular implementation, but that was done on the client side, so there were some problems with that. We wanted to have subdirectory enforcement, subdirectory not enforcement on the servers. There were challenges there, so we haven't moved forward with that yet.
So yeah, the question was, what about subdirectories? The answer to which is we haven't implemented that yet in Gluster. There have been some technical challenges, but we're still looking into it, I believe is the short answer. All right, do we got time for one more?
Yes.
All right, here we go.
So how can I define the redundancy level? So when I create the Venezuela, is there a way to say that, okay, I need a replica two pieces of every data, or is that a ability?
Yeah, you have the feature inside storage class. So when you create a volume, you can specify this storage class will create replica 3 and replica 2 or distributed replica. Those options are
Yeah.
there now.
Yes, by default it's replica 3.
Yeah, by
Yeah.
default it's replica 3. You can change it. I think the patch is there in Kubernetes now.
Yes. Okay.
So you're starting to log a topology file.
Yes.
Say you wanted to increase your cluster or deal with the failure. How do you do this? Do you have to edit the file?
No. At that point, you're dealing with Hecketi REST commands or using the Hecketi command line tool. You can add or remove devices and nodes that way. So. Yep, it's just initialization. And the question was, do we have to mess with the topology file every time we want to change the topology of the cluster? The answer is no. All right. Anything else? I saw one over here, right there.
Just kind of one more question there. The whole point of containers is that you can lose them almost any time. In case you want to bring a new one there with the same IP address, same host name, same configuration, you still need to rebalance or heal or at least reintroduce, join the whole cluster. Will Hecketi take care of this, or do you have to do it manually from last CLI?
Are you talking about rebalancing the storage?
Yes.
Oh, go ahead.
So yeah, so these volumes are mostly replicate. So heal happens without any command in Gluster. I mean, even in container or non-container case, replica. If you have 3 replica and Gluster node goes down, and something is returned to the volume, when the node comes up, the heal happens automatically on those nodes.
So as far as the storage is concerned, all the healing and rebalancing happens automatically on the Gluster backend.
Not rebalance.
No, rebalance? Oh, no.
Not rebalance, but heal happens.
Okay.
And we prefer replica volumes in this scenario.
Okay, so the rebalance doesn't happen automatically. Can you go into the backend and
Yeah.
force a rebalance? Okay.
So you can expand the volume created by Hecketi, right?
Yeah.
Yes.
And then who takes care of the rebalance? So is it going to be Hecketi or?
So this release we are doing the expansion part even more cleaner. So now Hecketi will take care of the rebrand. Yeah, expand.
Alrighty.
So here.
Yes.
Well, then the question was, if let's say I need to heal this token-based cluster, do I need to do anything special to get it introduced to say Hecketi?
Can you come up here?
Okay, maybe it's over. Thank you.
Apparently.
And don't forget to send a feedback, please. Thank you.
So the question is, since you have that level of Hecketi,
Thank you. Thank you again.
then let's say one of my containers, which is part of the cluster, is broken. And then how would I be able to like introduce another container and join it to the existing cluster?
Okay. So we are working on some solution for that now currently. So you can replace a node or replace a device which was already being used in case something goes wrong. So Hecketi itself will take care of all the bricks created and it will do rebalancing between all the containers from other.
And it's not like I use and
Yeah.
file.
You have separate commands too, not only topology files. You have separate commands. That is in progress now. It's not yet in Hecketi, but we are.
Do you have maybe, I don't know, like a vision of what could be used? I mean more or less towards production.
Replace node, replace bricks.
No, I mean because, for instance, in my case, for performance reasons, I'm not, because even if I run Gluster on new hardware, it's not as performant as something else. I would assume if I run the containers, it becomes slower. So I wonder what would be this kind of setup. I understand it gives you
The ability to manage everything. Manage everything from Kubernetes.
but then you might lose, some idle.
Salute.
Yes.
I'm not a captain.
But I have a hat.
You have a hat. I do too, but
How you doing?
not bad. I wanted to give you a little
Thank you.
heads up unrelated to this.
Yes.
StoreHog just got into Fedora.
Wait, what?
Wait, what?
Wait, what? Okay.
And I've got like 2 weeks or maybe 3 weeks to make 3.10 work with it. So I'm probably going to be calling you a lot.
Okay.
See.
Okay.
I don't know.
Are you
Actually,
gonna
I
be-
don't expect to have many problems, but
Are you going to be hanging out in Brno this week?
I'm all here all week.
Yeah, me too. So,
Okay.
so I'll be
Before
around
I
in
go
the
to
office.
FOSDEM on Friday. But, yeah.
Same here.
Okay.
Cool.
I'm going to FOSDEM. You are too.
Alrighty. What?
I don't think so.
Classic. Hey, how you doing? Awake, barely.
No, he's,
Did you just get in from Minneapolis today?
No, I got in from Minneapolis yesterday, but I literally yesterday.
Hi, I'm Cliff.
But I had a hell of a time getting up this
Do you
morning.
want to use
I didn't get on site until
I don't have
5
HDMI.
or 10
I only have
VGA?
VJ and MiniVGI.
well, Jose,
Only one with
So,
then
right
we
now,
are sure.
yes, thank you.
We are sure it works.
Okay. Oh, good.
Take your seat.
So yeah,
Yeah,
right now I'm
costly.
just, I want to get some coffee
What?
and then go about my day. Oh, thank you.
Yeah, it's good, dense information on Gluster.
Yeah, that's mostly a chic. I can't take much credit for that.
Okay. So this is same as
So
a
we'll be there. Okay.
screen.
Question, do we have to submit slides anywhere?
If you can do it on slideshare or something like that, and then
Okay.
send Chris a link to the slides.
Okay, sure.
Yeah. Thank you.
I'm giving a talk here later, and I
Okay.
realize my VGA adapter goes the wrong way, I suspect. Do I need to panic?
No, just came after this session, and we will try to solve it somehow. Yeah, we have
Yeah, because it's just
reactions.
mini DVI. But
Okay.
So for this session, it's not in the schedule?
It is in schedule, but it was changed. This was printed previous.
Can I know the speaker? Then I'll introduce.
Yes, of course. This speaker here. Oh, here. Clint Byron.
That's me.
Yeah. Nice flag.
Thanks.
Okay, please, in a QA session, repeat each question because
Okay.
of the recording. This is only one mic we have,
Okay.
so do not try to go anywhere.
Yeah, I'll stay right here.
For the talk, you have 40 minutes. For Q&A, there's 10 minutes if you would like to check it
Perfect.
somehow.
No, that's good.
Right. And I hope that's all. So, 5-minute breaks.
Great. Oh, it's fine. You're not starting yet.
Just borrow the internet connection.
Yeah.
For a while.
How do you pronounce your name? It's Clint Byron.
Byram, yes. Thank you.